Okay, so it's 7:50 p.m. on July 18th, 2020. This is the next video for Physics 5B. Looking at the canvas. Okay, what's new up here? First of all, well, there's the PowerPoint for Chapter 20. It's not complete, so you're gonna have to, after the exam, you want to download more from this. We've got the equations for Chapter 20. They look like this. No, they don't look like that. They look like this. Okay, so for the exam, you're interested in up to here. Okay, the other stuff down here, actually not even power. Not even, okay, actually I'm wrong. You only have to worry about, actually this. Okay, I'm not going to go into 20.3 and 20.4. I decided, I was going into that and I decided it's probably too much. So we're just going to have the exam from chapter 18, 19, and then 20.2, sections 1 and 2. Okay, so that's what it'll cover. Now, take care of old business. Number 64, there's some of the end of chapter 19. So you've got two chapter 19 problems, 63 and 65. So I've got 64 here. They're all similar. So in 64, this had to do with about the energy stored by a capacitor. So remember we had those different equations. You had the different equations. Let's see. So it's chapter 19.7 in Urone. So we had the different equations right there. So the energy stored in the capacitor. If you know the charge, you know the voltage, or you know 2 out of 3. You got charge, voltage, and capacitance. You know 2 of those 3. You could find the energy stored in the capacitor. Okay, so it's those equations right there. So on this one here, open heart surgery, a much smaller amount of energy will defibrillate the heart. What voltage is applied to an 8 microfarad capacitor of a heart defibrillator that stores 40 joules of energy? Find the amount. So what the equation, this one was probably E equals, what would it be? It'd be this one right here. You had V and C. So V and C, so there you got C, V squared over 2. So you solve this one for V. Okay, and that's where we get this equation here. So you plug in your numbers, 3.16 kilovolts. So what voltage is applied to an 8 microfarad capacitor? There's 8 microfarad capacitor of a heart defibrillator that stores 40 joules. There's your 40 joules of energy. Okay, so it would be 3.16 kilovolts. Find the amount of charge stored. Well, we just found out voltage, but then we also have those equations that include energy and charge, because we know the energy here. So we just solve for charge in one of the other equations, knowing the capacitance, and then, matter of fact, we can look at which one they're probably using. So there you have energy equals charge squared over 2c. So you solve for c, and actually you solve for charge, and you should get this equation right here. Square root, because charge is squared in that equation. So you just plug it in, and you get 25.3 millicoulombs. Okay, so that takes us out of chapter 19. Okay, and then we had PowerPoint number 20 is up. So let's go take a look at number 20. Starts off with current. Okay, so what is current? Electrical current is defined as the rate at which charge flows. So you've got it's electrons that are flowing. So the electrons are flowing from a lower voltage to a higher voltage. They flow from the more negative side of the battery to the more positive side of the battery. So that's the electron current flow. You have something else called conventional current flow, because more than 100 years ago they didn't even know what electrons were. They knew a current flowed. So they would draw it going from the positive side of the battery to the negative side of the battery. That's called conventional current flow. We now know it's actually the electrons that are flowing, so that would be electron current flow. So electrons flow from a lower potential, lower voltage, to a higher potential, higher voltage. This flow of charge carries energy. So in other words, you put a light bulb in this circuit, the current carries energy to your light bulb. Current is the amount of charge that passes by a point per second. Current has units of amperes or amps or just plain A. So it's basically going to be coulombs per second. And coulombs per second is an amp. Okay, so the amount of current that passes by per second, that's an amp. So current equals the amount of charge that passes by in a single second. So 1 amp would be 1 coulomb of charge passing by in a single second. So if 340 coulombs pass by in 8 seconds, then your delta Q, your charge would be 340 coulombs, your time would be 8 seconds, you'd have 42.5 amps, 42.5 coulombs per second passing by you. The number of charges per unit volume, A is the cross-sectional area, so they've got, we're going this, it's in your book. Okay, I don't really ask any questions of we need to do this, but the equation here, the current would be equal to, well, basically, we solve for, let's go what I have over here. So, Q equals NEAD. So what is it? That's the amount of charge that's in here. So what do we need to do? We need to find this volume. The volume is going to be the area, so there's area, times the length, or the distance here. So those two times each other would give you the volume. So then you take the number of electrons you have, how many electrons do we have, and the charge of 1 electron. Okay. Now the drift velocity, the velocity of the electrons, that's equal to the distance they travel divided by the time it takes them to travel that distance. Okay, so here's the distance they travel, how long does it take them to travel that distance. So T equals D over VD, that's what they have here, D over VD. They just solved for T in that equation. Alright, so I equals Q over T. Okay, I'm dropping the deltas here. So that's Q, we figured out was this, number of electrons times the charge of an electron times the area times the length of the cylinder we're looking at right here. We're modeling a wire right here. Divided by what T is, D over VD. Well, the D's cancel, V goes to the top, so I equals NEAVD. So that'd be the current that flows through there. Okay, so I think we can do a couple of these problems over here. So this is number 2 in Urone. You have number 1 in Urone and number 3. So number 2 in Urone, a total of 600 coulombs of charge passes through a flashlight in 0.5 hours. What is the average current? Well, there's 3,600 seconds in an hour. So you've got 600 coulombs in half an hour, 0.5 hours. And every 1 hour there are 3,600 seconds. So when we do this, we'll get coulombs per second, which is amps. So you get 0.3333 amps. We only want to have 3 digits of accuracy because that has 3 digits, that has 3 digits. So we end up saying 333 milliamps times 10 to the minus 3 amps. Find the current when 2 nanocoulombs jumps between your comb and hair over 0.500 microsecond time interval. Well, we've got the coulombs, 2.00 nanocoulombs. We've got the time, 0.5 microseconds. So we just divide them out, and we get a total current of 4 milliamps. 4 milliamps. And then here's another one, larger. So we got the current on this one. They gave us the current, they gave us the coulombs, and we want to know the time. So we just solve this for time. The time is going to be equal to change in the charge, that's the 30 coulombs, times the current, that's the 2. We go, well, they got 2 times 10 to the 4th. So yeah, you could write this as 2.00 times 10 to the 4th amps. So the duration of this lightning bolt, this lightning strike, is going to be 1.50 seconds. Okay, a fraction of a second, a little over a thousandth of a second. Okay, and I think this is going to be Ohm's Law. No, this is still current. Okay, so a defibrillator passes 12 amps of current through the torso of a person for 0.01 seconds. How much charge moves? Well, once again, we've got I equals delta Q over delta T. delta Q equals I delta T, 12 amps times 0.0100 seconds, or 0.120 coulombs. That's how much charge would move through this person's torso. How many electrons pass through the wires connected to the patient? Okay, well, the number of electrons would equal the total amount of charge that passed through, the 120 coulombs, divided by the charge of one single electron, because it's the electrons that are flowing. So how many electrons total? Okay, so we have this much charge. There's this much charge per one electron. So if you go the total amount of charge divided by the charge of one electron, you get the total number of electrons, which would be 7.50 times 10 to the 17 electrons. Okay, this one's also, it's got a lot of these. Okay, no, so 19, we got to go back to PowerPoint. All right, so a clock battery wears out after moving 10,000 coulombs of charge through a clock at a rate of 0.500 milliamps. So we have charge Q, we have the current I, so they're probably going to ask us about time, and yep, they're asking us about time. How long did the clock run? Okay, so we put that much charge through it at this rate, that many coulombs per second, 0.500 millicoulombs per second, so that's why it's 0.500 milliamps. So we solve for the time. We've got the coulombs, 10,000 coulombs. We got the current, so they're giving us 5.0 times 10 to the minus 4 amps. So there would have been so the clock would have run for 2.00 times 10 to the 7th seconds during that time. How many electrons thrown through? Well, we have the charge. It's the same thing we just did. We've got that much charge running through. We have that much current, actually. We got that much charge. What is that second? Okay, so hold on. The solution's in air. See, they've got delta Q here, but they put in the current, it looks like, coulombs per second. Oh, what did they want? How many electrons flowed per second? Never mind. We're trying to find the amount of electrons per second. So you get the number of coulombs per second. One electron has that many coulombs. This is correct. Never mind. This is correct. I was thinking it was like this one here, but it's not. Okay, so this is actually right. 5.00 times 10 to the minus 4 coulombs per second. That's the current. Okay, so how many electrons per second? Well, then you just take one electron, and to get that many coulombs in a second, there's that much charge per electron, so you would have 3.13 times 10 to the 15 electrons per second. Okay, now we need to go look at Ohm's Law. Okay, oops. Ohm's Law here. The current in a metal is directly proportional to the voltage applied to it. The more voltage you apply to a metal, the more current you're going to have flowing through the metal. The more electrons per second, the more charge per coulombs per second. So current goes as, or is proportional to, the voltage. This is known as Ohm's Law. Moving charges collide with atoms and molecules, transferring energy away from the current. Okay, that's a resistance. We're going to call that a resistance. It impedes the current flow, and this is known as resistance. This loss to waste thermal energy is a bit like energy loss to friction. Okay, so there's another way of we're losing energy. So the resistance is like a friction in the way of the flow of the current. So I, the current, directly proportional to the voltage, but inversely proportional to the resistance. So I equals V over R, where R is the resistance. R has units of ohms. Okay, the resistance is dependent on the, I've decided we're not going to do resistivity on this exam. It'll be coming after the exam. So resistivity, Ohm's Law, we have, resistivity and power. Okay, expect maybe those, I'll put another video out, hopefully Monday night, that won't be for your exam, but it'll be for the quiz on Thursday. So we'll try to clean up chapter 20, and then, so your exam on Tuesday, we'll go through Ohm's Law. Okay, so let's go, and your homework only goes through Ohm's Law too. So let's take a look at this guy again. So here's the first one. This is the first one that deals with Ohm's Law. Calculate the effective resistance. Don't get hung up on the word effective. They mean the resistance of a pocket calculator that has a 1.35 volt battery and through which 0.200 milliamps flows. Well, we had I equals V over R, so we'll just solve this for R. Basically, I should have written down the most common way to write this is V equals I times R. Usually when people say, what's Ohm's law? They'll say voltage equals current times resistance, okay? So I gave you that. So R, to solve for R in this equation, we've got the voltage, 1.35 volts. We've got the current, okay? So they just moved it over and made it a 10 to the minus 4 instead of 0.2 times 10 to the minus 3. So you get 6.75 times 10 to the third ohms, or 6.75 k ohms. That would be the effective resistance in your pocket calculator. And then this is the last, I believe, yeah. Okay, so this is the last. So 24 is in the next section. A power transmission line is hung from metal towers with glass insulators having a resistance of 1.00 times 10 to the ninth ohms. What current flows through the insulator if the voltage is 2000 k volts? Well, now you just use I equals V over R. You got the voltage here, you got the resistance here, and so you'd have 2.00 times 10 to the minus 4. Oops, there's supposed to be amps in there. Right. Okay, just when you download, just amps, there should be an A there for amps. So 0.200 milliamps. Okay, then again, my book is working fine now. I don't know what it was. I did a reboot, or not a reboot, reload, and now my book's okay, but I don't know what's going on with that. I don't know why it happened for a little while. So anyway, these are the problems you have. You have up to problem 20. Okay, so you can see they give you the current, they give you the voltage, you're going to ask for the resistance. They give you the voltage, they give you the resistance, they're asking you for the current. So very, very simple problems. Nobody should have a problem with them, I hope. So 1000 amps. Okay, so yeah, so anyway, and then these are back to the this is Ohm's law here. This is back to how long does it take. So this is our A equals Q over C, or Q over T, I mean, and so on. Okay, so so again, the exam's going to cover chapters 18, chapters 19, and only sections 1 through 2, but not all of 2, I don't think. Yeah, so, yeah, chapter 2. No, it covers all chapter 2. Chapter 2 is Ohm's Law. It doesn't, even though the PowerPoint goes on, see PowerPoint has a bunch of other stuff on it. I was going to put that on, but you know, it's getting late, I'm getting tired, I want to get this done tonight. So I decided, yeah, that's probably maybe too much to pile on you in a short period of time. Another thing, I'm not promising anything because I've never used Zoom before, but I'm going to try to figure out how to use Zoom tomorrow. I got to do other stuff too. I got my astronomy classes at Sac City. I've also going to try to put together like a review for the exam real quick. It'll be like 15 minutes, but I'll go through it real quick. A review for the exam, hopefully after I've already kind of made the exam, but I'm going to try to put that up, start uploading it tomorrow night, so it'll be there Monday morning hopefully. The other thing I'm going to try to do is figure out how to use Zoom. I know there's a couple students I think want to meet with me in person over Zoom, but then I'll try to do this thing where the whole class is invited, but it'll be voluntary, you don't have to come. I'll try to, if I figure out Zoom tomorrow, I'll let you know. I got to figure out how to use Zoom. I've never used Zoom before, so I'll try to use Zoom on Monday, and then Tuesday will be the exam, and I think that's everything. And then we'll go on from there. You'll have stuff about the resistivity and power, especially power, electrical circuits, power. That's important. Resistivity, don't have to spend a lot of time on that. Okay, I think that's everything. You've got everything up on your, what's going on here? You got all this stuff up here. You got your chapter 20. Okay, I don't have I'll put a time for you to turn this assignment in. I don't have it up here now. I'll do it tomorrow. It'll be due the same day. So worksheet number 2 was supposed to be a while ago. I guess I forgot to put up the thing, worksheet number 3. So basically, it's just all going to be, just turn them in on the 21st when the exams. So you got till midnight or actually 11:59 p.m. on the 21st to turn them in. And that's the same day as the exam, correct? Yeah, that's the same day as the exam. Okay, so I think that's everything. Let me say good night, and I'll hopefully talk to you tomorrow, and maybe with a Zoom session on Monday, but let me figure out how to use Zoom. I don't know how to use it at all right now.